So people who has a different number of rows for input guideline, that is because of the MSstat version, and that is because of R version. So if you upgrade R version 3.5, then you can upgrade MSstat version 3.12. What I'm worrying about is OpenMS converter. That is quite new, so it will be only available in 3.12. So I recommend to upgrade our version 3.5. And if you have an issue for that, please let us know. The TAs will try to help you install that part. So R? Yeah. I can, yes, potentially yes. So TAs have a flash drive with the source file, or you can go to the Bioconductor. You go to the Bioconductor MSstat. So this is, okay, 3.7 Bioconductor. Here's the source file. So you can download it and then install it. Do you know how to install it? Yeah. So here you can save it and then install it. How many people try to optional challenging? So use another output from different processing tool and to make an input format? No one? No one? Okay. Then, okay. Then let's try it together. So this is our folder. Okay, I will bring my computer. Okay, then I will open the new R script for OpenMS. So here, this is analysis for OpenMS output. At the same directory, here's the OpenMS data. So I will read raw file, read CSV, data, OpenMS, and ABRF. And I check how the data look like. So under the data OpenMS folder, OpenMS raw CSV file is quantify the data from OpenMS for same IPRG data. So now I have a raw data would include OpenMS. Everyone get it so far? Profile? Okay. Then how it look like? So OpenMS output, protein name, peptide sequence, precursor charge. So pretty much already kind of the setup for MS that require format is already condition information and biological replicate information. As I know, what we made an annotation file, it should be one of the input for MSstat, OpenMS, and automatically they merge that and then report the MSstat report format. So at this moment, we don't need to add the annotation one. So let's check how the annotation look like. Let's check unique row condition run and the bioreplicate. Here we have a 1, 2, 3, 4, 4 conditions, and then run 1 to 12, and then biological replicate information same as before. Okay. Then here's what OpenMS converter function doing. So something is similar, something is not similar. So just small things, rename column and so on, and then remove the shared peptide same as before. And then this is the high issue for most of the tool, except the Skyline. If you have your own processing script and then want to make a MSstat require format, this is the key part you have to check it. Commonly, I can find that there are multiple measurements per protein per run. We expect for specific run, for specific feature, we expect only one intensity value. However, sometimes not. So there are two types of the multiple measurement. I don't know what's going on, but actually they do completely duplicate row, which means completely same information, but actually they report it twice or 3 times or 4 times. I think there are some just not that they are not that much careful about this one. Probably when they quantify something, maybe. At this moment, I just completely duplicate a row, or sometimes for a specific feature, for a specific run, they report a different measurement with the multiple row. Then we have to know, so what we have to do, why they have some different value. It can be some different memory G value, and maybe something else. In that case, if the processing tool level consider this one and then report the correct format, is perfectly good. That is what we expect. But we actually look at the many different cases, but there's no what is the best way or correct way. So in that case, we just aggregate this multiple measurement for that specific run. At this moment, we recommend our default is max, means just use the maximum intensity if they have a multiple measurement. However, you can just change this one is summation of intensity or median or anything else. And then also we just do the remove some feature, have any missing value, and less some specific measurement across the MS run. So then, and then same thing, I will make an input OpenMS, and then OpenMS converter function. Then row file is our input, and then I will use the same option as Skyline. I want to remove the protein with only one features. So here DDA cases, the feature will be peptide and charge combination. So I will run. And then it actually, when they are doing something, they just report output. So for example, more than 900 features. So it says, here's the progress. So they check the data, and then 0 feature have all NA or all 0, and then all peptide are unique. So they're gonna keep all the peptide. And then more than 900 features have 1 or 2 intensity across the 12 MS run. So we are gonna remove it. And then here 700 protein, around 700 protein have only one feature, so we are gonna remove among this number. So we are quite like almost 25% protein will lose. And then here's no multiple measurement in this data and so on. So it actually showed all the progress. Then if you are ready, I will save this intermediate result in the OpenMS folder. Save input OpenMS file dot dash data OpenMS input OpenMS RDA. Then here's the next step. So far we are talking about how do we clean up the data, and then let's start our first main function. So I call this is data process, and then it has many steps. The first, what this step do is, first we do the log2 transformation for intensity value for because log2 scale value is more suitable for normal distributions, so which is more suitable for all next downstream analysis. And then we do the normalization as what Olga explained this morning. So for DDA, DI case, the always default is equalize the median, means make a median log2 intensity is equal. And the SRM case also yes, if they have a heavy labeled peptide injected. And then if you have a global standard protein, yes, we can do it. However, if you have very few number of the proteins, and then if you don't have any spike in edge control, I do not recommend this. So we are going to practice this one for the next this program for capstone, because this is not suitable for our assumption for normalization. So for normalization, we provide the 3 different options. However, we also offer the last one, no normalization, which means you can normalize the data as you want for your experiment, and then just use your normalized intensity for next analysis. Third step is decide the sensor threshold. This is what Olga showed. Just draw the whole log2 intensity, and then decide some lower abundance threshold for that specific data, and then ignore under that threshold will be just really low, and then we need to impute it. So after we decide this one, and then we impute the censored missing. If you assign the random missing, we are not going to impute it. How we can distinguish random and censored is really depending on the processing tools. Skyline offer 2 different missing value, NA random, 0 censored, and other tools no distinguishable. They report 0 or NA, and we just recommend to any missing value just impute it. This is so far actually have a better performance than no imputations. And then this based on Tukey median, the robust run summarizations. So this whole step actually happened this data processing. This is quite, it takes long. If you pass this one, everything will be just very simple. So let's try to do this. So I will go back to the Skyline input files. So let's double check. We have an input Skyline here. Yes, we have an input Skyline. And then here is the data processing step. I will save this processed data to quant skyline, and then data processor function, and then open it. First, what we need is I said, okay, the data should be input skyline. I will use this. If you only put this and enter, actually they're going to process with all the default options. But what actually here is the main option is log2 transformation, and then normalization equal equalized median S, and summarized method is by Tukey median. Model-based input is true. If you use setup, this is false, no imputation. And then if you want to impute which value you want to impute it, censored intensity should be 0 in skyline case. So if you just want to use all the default method, everything you don't need to assign it. However, only option you should care about is this values. Progenesis skyline should be 0. Max quant OpenMS should be NA. But I will tell you how you can decide this one. And then other option is cutoff sensor. So for imputation algorithm, we know which one should be censored intensity and then imputed. Here's one of the parameter we need to set up. Okay, then, so from where, like what kind of the guideline value we have to use for feature? That is this option. So let's just make a guideline. When you impute, just use the minimum value of each feature. That will be your guideline, and then just use another model for that. That is options. This is maximum quantile for censored, means when we decide the censored threshold, when we draw this curve, we just want to guide from, this is the default, from 99.9 percentile, we think this is kind of maximum, and then use same width to define the low threshold. So that is the main options, right? But only you need to worry about this input and then censored. Okay. Then run. It will take some time. I think now this computer is now recording, so it's quite slower than normal. But for this case, is kind of up to 5 minutes it will take. So it keeps showing what's going on over there. So here it says more than 2000 intensity is 0 or less than 1. We also treat less than 1 value is just 0, because 0.05 or something, if you do like log transform, it will be minus really huge numbers. So between the 0 to 1, we also treat this as just 0 value for log 2 scales. So if you want to use this platform, some different type of the data, this part you have to be care about it. So here's the big assumptions. So in this case, intensity value should be 1 to bigger. So if you have data set ratio, which means it can potentially have a minus value or 0.0 or something like this, you have to think about this one before you use. So, and here it says, okay, here low to intensity under cutoff 16.5 0.343, this is kind of our threshold for the censored, what we defined here. And then here it says we used all feature for all feature in this data set. This is just also extra one. There's an option. You can use top 1 or top 3, top 5 features or top n feature, especially for DIA case, if you want to reduce the number of the features. We are developing some feature selection method, which actually can select the most informative features. Not published yet. So we hope that we can make this available very soon. Here is also the summary of your data set, what MSstats found. For example, here, there are 3,018 proteins are there. And then for each protein, there are 2 to more than like 170 peptide there. Does it make sense? Because we remove the protein which have only 1 features. So here always we have more than 2. And then here, because this is DDA case, there is a 1 transition or a fragment for each peptide ion. And then it also show the experiment design, what the MSstats detected. For example, for condition 1, they have a 3 MS run, and then 1 biological replicate, and then 3 technical replicate. If this report is different than your experiment, you have to consider like where's the problem. You have to go back to the annotation file or something else, you have to recheck it. So here, okay, for my cases, 43-45%. If anybody who has a problem, please put the red one. And then if you have any questions so far, please let me know. If you got, if you succeed this line, could you put the blue one? I just want to double check how many people got the result. Okay, so if people succeed, let's try to look at more detail what the output look like. So the quant skyline, what we made is not a data frame. This is a list, which means that, include several informations. So you can check names, quant skyline, and it actually have 5 different data inside. So first is the processed data. Processed data is a little bit reformatted data from our input skyline. They have extra columns. They have a normalized data and then mark which one is censored or not and so on. But pretty much from original data, but add some extra column. The reason why I report this, first, we want to draw the visualization for our original data. Second, you can use this data for your next analysis if you want to do something else. So how it look like? Head, quant skyline, processed data, here is the data look like. So it has a protein info, peptide, transition, features, and so on. Subject and intensity and abundance. You can see now this we call abundance. It's log transformed and normalized data, which we are going to use next analysis, and fractions. If you have a fraction information, you have to add this fraction information in annotations. So now, before I just show run, condition, and biological replicate, but fraction, you can add your fraction information. If you have a technical replicate, you also can add a technical replicate over there. So if fraction information available in your annotation, the MSstats add this information here, and then show the original run original run information and then censored. This is what we flag. Should be censored and then should be imputed and so on. This is the processed data. And next data frame is run level data, means summarized data from processed data, what we talk about it. Imputation and the Tukey median, Tukey median based summarizations. So what this data has, it has run and protein. So for that specific run, therefore specific protein, here is the summarized values. So this is the summarized value we are going to use for next analysis. And for this one is a summarized value across the features. So here we showed how many measurements or how many features we use to summarize this log intensity. And then how many missing percentage there, and then more than 50% missing or not. So if I go back to the one of the question from last section, if Tukey median, if you just put the 0 for missing value, if you set 1, like 10, 10, 0, 0, 0, 0, 0, what is the median? It's 0, right? So we should expect like some between the 0 and the 10. So that's why we want to impute the something instead of the 0. We just want to impute something. So if you have a more than 50% of the missing across the feature versus that specific run, actually the Tukey median and the imputed value is kind of the matter, and then make the summarized value difference. So that is the main things. Other thing is to have just a simple informations. Then what I want to do is a visualization of the data. So after I go through this visualization data, I will give you some small challenges, and then I will go over the people who has actually have the problem. So next one is actually I used most frequently. So visualization. For visualization, we have a function data process plot. Data process plot, which has many options. And then we provide 3 different plots. One we call a profile plot, which showed all the individual value and also summarize the value. So let's practice this profile plot first. So data process plot from quant skyline. So input for data process value should be output of the data processing function. From this one, type, we need to define which type of the plot do you want. Profile plot. And address is actually you can define some prefix for your PDF file. So I will say skyline spike 1. Just spike 1. And don't enter or don't run. If you click here, it will gonna generate for all protein profile plot for all the proteins. It takes a while. Like it takes like 20 minutes or 30 minutes and so on. So what I can do, we can just draw only specific one proteins. Let's try to draw one by one, which are the spiking protein we want to look at it. So this is hard part. So I need to type the protein name. So which proteins? And then you can type the name. So here is the one of the proteins we spike in. So SP and pipe. This is not L, not 1. Pipe sign P44015 and pipe VAC2 East. and then it has a lot of the features, so our feature name should be NA. I don't want to see the feature name. And then let's define this is under the data skyline. So from the data was processed, I want to draw the profile plot, but I want to hide the feature name. And then please draw the profile plot for this specific one proteins, and then save the PDF file here. Okay? And then I run. Then, okay, here it says, I draw the profile plot for this specific protein. And it said, I draw the profile plot with summarization for this protein, right? So basically it says to plot the drawing. So I will double check the file and then go back to the data skyline folder. And then now I can see here, I have two files. Two files here, right? I will open the first one. So one spiking protein with the profile. So here we go. It shows all the individual intensity from that specific proteins. So this is the one of the spiking protein. We know it should be different amount across the conditions. So here, and then lower and low. And then each line is for peptide ion. Each dot is each measurement. And then you can see, especially this purple one have really huge outlier for condition 4, or they have like the variation for condition 4, and then especially here they have a 0 missing value and so on. So the goal for this one, I want to see how actually data look like for this specific case. Another thing is, if you can see it here, if you see there are some you should have some problem. You can go back to the processing tool. For example, Skyline, you can double check how the chromatography look like. And then if there are some issue for processing step, you can fix it and then you can come back again. So that is the goal for this profile plot. So I drew the one profile plot, but originally you can generate for more than 3,000 proteins. And here, another plot, the profile plot with the summarization. So same thing, but here I make all the measurement is a gray color, and then add summarized value. So this is from processed data from output, and then processed data, and the red one is run level data. We are gonna use this run level data for our inference stage. So we are not use original data anymore. Okay, so this run level data is what we are gonna use. Okay. Then I will give you some small activity. So here is the protein ID for other 5 spiking proteins. Please draw the profile plot and summarize the plot for this 5. And then just see, you can compare, actually their behavior is similar as what we expect. For example, from first, like this. You can compare their their summarized value, how consistent with this one. So here's the 5 protein list. So during the activity, I will go around. So if you have a problem, please let me know. people who have clustering issues, some TA bring the different version. I'm sorry, but I don't know what was the issue. It actually recently I also found it. The TA will give you the 11.7 version, sorry, and here you should enter clusters NER. That is only for people who have a 11.7 version from the TA. Otherwise, don't change this. So people have a cluster issue and reinstall it. Please put this option over there.
This means that we can only use single process to run?
Yes. So I tried to, what is the problem for cluster, this one? Most likely it looked like some firework, like some security issue, but so far I don't have solution. So I just make some different version to not use the cluster and it works. So let's try to make one of them from my side. So what I will gonna do, just same thing, right? So I will completely copy these functions, and then I will just change the protein name. So let's see this one, 55249. Just copy this name. I replace here, and then I will replace this as 2, and then I will run it. And then I have 2 new plots there. Wow, this will look like this. And then I will go back to our concentration. I want to compare. So here, so this is a 55249. So the middle condition should be huge, larger than the other one. And then 1 and 3 should be really similar to each other. And then this is smaller. And then let's see here. Yeah, so this is really up. And then the other one is flat. And I can see still like there's a lot of the variation or noisy under the, like at the lower abundance one. Okay, so that is one of the plot for profile plot. And the another things I also frequently check is the QC plot, quality control plot. Basically want to double check that our normalization is working well or not, or just whole distributions. So I will just copy this one too. But this is a QC plot. So it should be changed this instead of this profile, it should be QC. And for QC plot, the QC plot for each protein is not that much meaningful, but what I usually check is QC plot across all proteins. So I said all only, which means want to QC plot for all protein, not by each protein. So I run this line. So these 2 line, what I change it. And it takes a little bit longer than before because the R need to plot all individual measurement for whole data set. So here it looked like some not good message. They said warning message, but don't worry, it says warning, not error at least. So just give you the warning. What warning means here, I removed the 184 rows, which actually they have an NA value. They say I just ignore this NA value, and this is just warning, so you don't need to worry. And then here now you can see the Skyline QC plot PDF. So here is our QC plot. So you can see now this median. For each box, this line shows the median value, and then now this is equal. And then now still we can see there are some outlier for lower abundance one, and then there's 0 values over here.
Is there a before normalization?
Yes?
So this is post normalization? Is there a plot for before?
It's after. This is after, because in the data processing we already set up the normalized equalizer median, and then output, we use the output of the data processing to draw this one. So this is already normalized data. If you want to double check how it looked like before, in the data processing you can say normalized false. So so for example, if you want to double check how it looked like before normalization, here, instead of here, you can say false. False means no normalization, and then saved no normalized data, and then to here, and then you can this output of this function and for the QC plot. Yes. So that is the QC plot. Also, another thing is condition plot. The condition plot means I want to summarize the intensity value for each condition, but not statistically used, just mean and just standard deviation or standard error. No statistical method for that. So same things, but here, condition. In this one also we plot by each protein. So I will copy one of our protein name and then replace this. And then I will say this is a spike 2. So only you should change this part and then which proteins. And now here I can see there is a condition plot like this. So this is just without any inference. So just calculate the mean across the 3 replicate, 3 summarized value, and then standard deviation, and then so on. So here you can see this is have a large standard deviation, and then local world is a smaller. So this is just preliminarily descriptive the plot. Is it okay so far? Yes. You can draw any kind of the error, but this is not our recommendation, because we are use this summarized value and then more advanced statistical analysis for next step. And then after next step, we also provide how to summarize based on their variation calculation. So this is not recommendation for us, just give you some brief idea. So we are gonna work for next step for that. Okay, so far? Then let's move on to the OpenMS. So this is the step for data processing. So after we filter out, just to run the data process file and then go through all the visualization and then check your data set. So then I will move on to the OpenMS one. So we already have the OpenMS input, right? Then it also should be same function. So what we want to do is quant OpenMS, and then I will use the data process function, and then input should be input OpenMS, and then I will use all the default functions. And here what I need to change is censored into is NA. So this is the difference. Because before I run, maybe we can double check NA value and NA 0 value, how much they have. So sum is any NA input OpenMS intensity. So it actually count how many NA values in intensity columns. Can you see there are like this much large number of NA value here? And then let's check how many 0 value we have. So not NA and input OpenMS intensity value is less than 1. So which means basically count intensity value is less than 1. So 0. So OpenMS actually not generate any 0 values. Actually, they have internally already have some threshold for lower abundance 1 and max quant 2. And then maybe we can check here range of intensity, which is input OpenMS This is the range of the intensity value what OpenMS generated. So here already start a very huge, large number of large, like the big intensity. So for processed data, here, this is the run for data processing for OpenMS. Just change this and then change input, and then it will take like 4 or 5 minutes. Cluster issue, our TA have a different version, 11.7. So after run this, and don't forget here, comma, clusters nurse. Like, so which have, this is only for people who have a cluster issue before.
I have the solutions. Can use the R3.43, then you can not use the 3.5 and fix.
It fixed?
Yeah, you can use cluster. I'm running now.
Okay.
And then what
MSstats use the one. This is the R version.
Oh, let's see.
I just installed from the source the drg.gz. Yeah.
People who have this quant OpenMS, please draw the profile plot for same proteins, and then please compare profile plot and summarize value too with skyline output. Actually, they look quite different.
Which normalization you use for OpenMS?
Equalize.
Equalize
With media.
medians?
Yes.
Okay.
Cannot be done. Why?
They have an arrow match the same. Cannot summarize with TMP. Okay.
So I draw the one example for OpenMS one. Okay, here you go. I drew this plot. Let's open two of this. So this is the same plot, same protein. What we draw for skyline. If anybody can remember, we had this line and a huge slope lower value, and then for skyline we can see there are like some outliers here, and then very noisy. And then this is the same protein, and then from OpenMS, you can see here we have several, like around 10 features are there. However, it's going down, and then from this point, completely missing, right? So internally they apply some threshold, and then there's no value. So without the imputation, if you want to summarize, actually like if you just a median of this, median, and then median. So it will be quite, very flat across the condition, which is what we not expected, right? So our imputation algorithm, based on this measurement, we impute the submixing value here, like it will be somewhere this here, and then this is the summarized value. So even though here we have a value over only above this yellow line, because there are hidden imputed value, we can see here is our final, the summarized value, and then use this value for our inference. Okay? So if you can draw another one, but we draw here, also here I just changed, this one is OpenMS, same thing, I just changed the folder, OpenMS, and save this profile plot under this folder. This is the another one. Here. Here, also same thing. Under the some threshold, we are completely lost value. However, after we imputed and summarized, we can see the similar pattern as what expected. So this is the OpenMS one. So the reason why I want to show this one, actually the data itself it will be different by the processing tool, because they have a different algorithm for filtering or quantify or, and so on. So you have to be careful about this one. So that is for our processing part. So next section, I will move on to the group comparison and subject quantification. However, if you want to practice the same thing for progenesis and also for the max quant. So if there's a folder, so just few lines, just copy the same thing, but just double check the missing value and then replace the censored intensity 0 or NA, and then you can automatically generate it. Okay. So please practice, or you can just draw something else, some background protein, how it look like, and then please let me know. I will go around and then answer your questions.